In this video, I review the steps required to diagnose a Perkins 4108 marine engine that is overheating. Of course, I should be checking the sea strainer, and so I've got this nice handy wrench that kind of a universal, I don't know, there's a name for it, I just don't remember what it's called. I'm going to check the sea strainer shortly. Oh, look what I've got. Goodness. Ugh. What is that? Definitely caught something in there. Looks like some fishing line. Ugh. Well, I'll be digging that out. Well, it turns out it wasn't as bad as I thought. Here's the strainer after I've shaken everything out. Probably cringing at the sight of seaweed, etc. all over my soul, but oh well. Anyway, the strainer's cleaned out. The raw water hose comes into the sea strainer. And as you can see, it reduces here, and I actually removed the sea strainer and then I attached the same hose as I used diameter forward, that 1/2 inch hose, and ran it into a bucket and measured the throughput at that point. Then of course through the impeller up through this tube which goes up and then back down into the heat exchanger with the vent that is up above. My impeller had this little rubber gasket over the cap, over the end, like that. Had to kind of just pop that off, and then it seems to come out pretty easily. Mine is coming out pretty easily by just taking a screwdriver and carefully wiggling it. Now I think it should probably come out just with a little bit of twisting. Not all of the flaps are in the right direction, but as you can see, I mean, this is how it should be turning, so they should all be pointing that way. There, just got it off. So impeller looks fine. Well, I'm back to checking the heat exchanger for any blockage for the raw water passing through. I went searching for some flexible rod, stainless steel rod. Just ended up going to Home Depot and getting some threaded rod. I grabbed a 1/4 inch. That's this, and as you can see, it just doesn't quite fit. So I'll be returning that. I also got a 3/16 inch, which is slightly smaller, but it'll do, I guess. And sit there, and there it is. I can feel it seating on the other side, which I believe, well, I know it's the rubber gasket that goes on the other side. At least I believe it is. Now that's, I'm guessing, probably a piece of the pipe that is sticking against. So I'm going to go through each one of these holes and make sure there aren't any obstructions, but I really don't think there are. I ran a little pipe through the holes on the intake side. It all seemed clear, but I wanted to take it off anyway and make sure that everything else looked fine. So I've just popped the other side off, and everything was clear. I also noted that where the rubber cap was, because I thought that maybe some of the coolant, some of the holes were blocked because it might have been too tight, but in fact it was about like that. Had a nice big fat finger width of space where the raw water would come out and then get reduced down to the smaller hose here. So taking that off, I've also removed the riser. Looks like I broke the gasket. I'll have to replace that. Of course, when I pulled the end off, I had a lot more antifreeze seeping out, which I quickly grabbed the vacuum and was able to save losing too much of it down into the bilge. So looks like there's a little bit of exhaust. I don't know if that's terrible, but one thing I've heard is that if you take the heat exchanger off, you should have it boiled by a radiator shop. Make sure there's nothing else that's causing serious problems. But clearly, where the raw water passes through, it looks pretty clean. I don't know if you can see that well. I'll try shining a light down inside, but it looks relatively clean. I mean, it looks like brand new, actually. So I'd say my heat exchanger looks good. The flow looks fine. I know I'm guilty of overthinking all of this, but I started putting everything back together on the raw water side, and I came across this situation here where the exhaust manifold comes down to the riser where the raw water goes through the heat exchanger. There's enough give that all of this could actually be sloppily reattached in that kind of a position, which I think would definitely not be the best passage. So I'm working on making sure that I install the raw water tubes further back so that I have about a ½ inch when the heat exchanger, when the riser is attached and the everything's hooked up. Where I just left off, I wasn't happy about the ½ inch gap, and now I have a 1 inch gap between the end of the tubes and where the water needs to flow. That's because I cut off about a ½ inch of this pipe. So we're testing the thermostat, and I was able to pry it up high enough that I could pull the thermostat out without actually removing the clamp on the hose. I don't know if others have a different approach. And in the meantime, I have the thermostat in the pot of water, and I'm using a infrared temperature gauge. I'm actually measuring the temperature of the thermostat, 131 degrees right now. Anyway, I'll keep monitoring this. Okay, here's a good angle of it open. It looks like closer to what I would expect if you see the red where I'm shining back and forth, where it's, I think a good 3/8 of an inch. And that's what it's supposed to be at its max. And right now it's reading my infrared gun is reading 192 on the thermostat. So wide open, I'd say that's good. And confirming it's opened at about looks like my 3/8 of an inch. I'm reading from the 1 inch mark, but yeah, it's looking very close to 3/8, maybe a little under that. I believe that's right. I took it out. I'm watching it, and as you can see, it's quickly returning to its closed position. I stopped at 195 degrees. I had a pretty small burner, which was having a tough time bringing the temperature to full boil. But I'm convinced my thermostat is working perfectly fine. Whoops. Next step is to check the flow through the riser. I had this riser replaced a while ago, and I guess that's the mixer, and then make sure I don't have any obstructions on the exhaust. Okay, so I ran a snake down the exhaust pipe, and you know, I didn't have enough length to actually see it go out the other end, but I ran 16 feet, and it's only um, it's only 12 feet, maybe it's only about 14, actually 14 or 15 feet, counting the curvature of the hose. So what happened is the snake kind of started wrapping up inside, and so I decided that was good enough, and I hadn't felt really any resistance at all, other than the fact that it's just a snake trying to move with difficulty. So then I went ahead and I packed a rag around a hose and stuck it in the exhaust pipe, and that's what we have here. And then I ran the hose all the way up to attach it to a hose outside, and I'm running fresh water through it, and it seems to be flowing just fine. So I've concluded that there really is nothing wrong with my output exhaust. I also checked the mixer and the riser, and they're all fine. The next thing, I guess, is to go to the freshwater pump and make sure that that's all working. So I loosened the fan belt, and after removing the V-belt entirely, spinning it, bearing seems really good, but I just don't feel any fluid in there, what I would think fluid would feel like. On a long shot, decided to go ahead and pull the freshwater pump, and even though, you know, in a previous episode I tried spinning it, bearings felt fine, but I couldn't feel any resistance. But you can see why you wouldn't feel any resistance. This is very heavy, very little water. I mean, antifreeze water mixture you're not gonna feel anything. So there's nothing wrong, but peace of mind. I know now that my freshwater pump is fine, so now I have to go buy a new freshwater pump gasket, clean this up, put it back on. A little bit of rust here, but I don't think it's anything to be worried about. In fact, I'm not thinking that flushing the fresh water side is even going to make a difference. It's just, I'm not finding any obstructions. I'm not finding anything that would suggest that my freshwater cooling is inadequate. The raw water intake, that's I'm going to show that down here. 2 gallons per minute coming through the through hole directly. From there it goes through the gearbox cooler. I never took this off. I don't really think there's any place that things could get caught. It just basically has a surface that is against the gearbox, that when the water runs through, it helps keep the gearbox cool. It's actually an optional add-on. Some engines don't have this, so I didn't trouble any further getting these connections off. They're very, very secure. This hose goes all the way to the back, roughly 6 feet, to the C strainer. And once again, I checked the flow at the C strainer. Now, with roughly 6 feet of this hose, the measurement went from 2 gallons per minute to roughly 1 gallon per minute, using this size hose, which is because although the hose running to the back is larger, it is reduced down to this diameter, and then I'm losing some of the flow even by cutting it down the inside dimensions of this tube. So it's probably better than 1 gallon per minute. And then finally, I checked the flow after I got the engine running at at 1000 RPM and at 2000 RPM throughout the exhaust. And so I basically took a 5-gallon container and diverted the water out the exhaust so I could catch all of it, and I was getting 3 gallons per minute at 1000 RPM, which is roughly my idle, and 6 gallons per minute at 2000 RPM. So that all seems like pretty good flow results. January 1st, 2016, Happy New Year, I got everything back together. I added new coolant and started the engine after reconnecting the muffler, the heat exchanger, the tube stack inside the heat exchanger, all the gaskets, made sure everything was tightened down. Ran the engine, checked for leaks. I had one leak around where the thermostat goes. Retightened that, and everything else looked good. So I at dock ran the engine at 2000 RPM and was happy to see that the temperature was 160 degrees, I believe. Yep, 160 degrees at 2000 RPM after running it for a good half hour. You know, there were several areas where there was minor obstruction, like in the C strainer there was a little bit of debris. The connectors coming out of the tube stack and going into the tube stack, I actually cut the pipe back a little bit so that I had more free area for the raw water to go through. And then on the back, the pipe was actually, I'll come around and show that. The pipe going past the impeller and going up, it's a looping pipe, and it goes up, but right here where the pipe it used to be really down low, and I felt like maybe there was some obstruction there too, so I cut off about an inch of this pipe. It was really long, and so now it ends just about right there. Comes up, comes back down, and goes in here, so into the heat exchanger. So I did that. I had the debris in the C strainer that I cleaned out, and I cleaned out the through hole, and I blew out the exhaust pipe, the exhaust line after running a snake through it. Just blew it out with a water hose under pressure with a rag packed around. So confirmed that everything on the raw water side was flowing as best as I could ever hope for. I took Solus out yesterday for the C trial. The C temperature was 62 degrees, and I started out going out here. I'm in Mission Bay, San Diego, and through the jetties, you know, at the 5 mile an hour point, roughly 1500 RPM, and the temperature was 160 degrees. After passing the 5 mile an hour buoy, I put it up to put the Perkins up to 2000 RPM. Temperature rose to 164 degrees, and we were going about 4.5 knots. And after I was out in the sea, I cranked it up to 2500 RPM, and Solus goes 5.6 knots. She should have a boat speed of about 8 knots. She's 42 feet. And temperature rose to 168 degrees. Did that for some time. Then I cranked it up to 3000 RPM, and temperature rose to 176 degrees. So I'm feeling pretty good. Speed 6.2 knots, and at 176 degrees, it remained steady at 3,000 RPM. I probably ran a good 20 minutes at that speed. The engine sounds so loud at 3,000, I just don't even like to go any higher than that, but I thought I should go ahead and try. So I did the maximum that the engine would go, which was 3,600 RPM. I had marginally better boat speed of 6.7 knots, and within a couple of minutes the temperature rose to 190 degrees, which I think is too hot. And I quickly put it down after 2 minutes back to 3,000 RPM. Yeah, it was time. She cooled back down to about 179 degrees. But there was smoke kind of coming off of the block. It seemed very uncomfortable at 3,600 RPM. The Solus was built in '84, so the engine is 30 years old, 32 years old, I guess. So I would say for a 32-year-old engine, she's doing pretty good.